In this video, we're going to solve a related rates problem using trigonometric functions. So here's the problem. A camera placed on the ground is used to follow the movement of a rocket from a distance of 5 kilometers. As the rocket is moving vertically upward, the angle of elevation with respect to the camera is increasing at the rate of 3 degrees per second at the instant when the angle of elevation is 45 degrees. What is the speed of the rocket at that instant? So let's say this is where the camera is placed, okay? And then this is the starting point of the rocket. According to the problem, the camera is placed on the ground from a distance of 5 kilometers from where the rocket is. So we have here 5 kilometers. As the rocket is moving vertically upward, so let's draw a line representing the movement of the rocket vertically upward. So let's say this is where the rocket is at any point in time after its takeoff. And then the camera is following the movement of the rocket. So we can draw a line here from the camera to the rocket. We now have a right triangle where this angle here, angle theta, is the angle of elevation of the rocket. This distance here will change over time. Okay, so we can call it, for example, x kilometers at any time. We also have here the rate of change of the angle of elevation. So d theta dt equals 3 degrees per second. Now what we have here is an angle measurement in degrees. Okay, we really cannot combine the degree unit with the units in the linear measurement unless we take its trigonometric function value, because then it will be converted into the same scale as linear measurements. That's why in calculations, especially in calculus, we always work with radians. Okay, the radian unit allows us to relate angle measurements with linear measurements. In other words, it brings the angle measurements on the same scale as the linear measurements. Okay, so first we need to convert this degree unit to radian unit. Okay, using the conversion factor pi over 180 degrees. Okay, so this will now be equal to 3 over 180, that's 1 over 60. So we have pi over 60 radians per second. Okay, so what we are required to find here is the speed of the rocket at the instant when the angle of elevation is 45 degrees. The speed of the rocket is the same as the rate of change of x over time. So basically we want to find dx dt at the instant when the angle of elevation, which is theta, equals 45 degrees. Or 45 degrees in radians is pi over 4. Now let us set up our working equation. We are given an angle measurement. We are given an angle measurement that is changing over time. So obviously, we need to apply trigonometric functions. If you look at the right triangle here, opposite angle theta is x, and then adjacent to angle theta is 5 kilometers. So we need to use a trigo function that involves opposite side and the adjacent side. Okay, and that would be tangent function. Okay, so tangent of theta equals the opposite side, which is x, over the adjacent side, which is 5 kilometers. Okay. Next, we differentiate implicitly with respect to time. So the derivative of tangent of theta with respect to time, derivative of the tangent function is secant squared. In this case, theta times d theta dt equals, so we have here 1 over 5. Derivative of x with respect to time, that's dx dt. Next, we can isolate dx dt because that's what we are required to find, right? So dx dt equals cross multiply 5, so we get 5 divided by reciprocal of secant is cosine, right? So 5 divided by cosine squared theta times d theta dt. Okay, so we can now plug in the values, the known quantities. We have here 5 cosine theta, cosine, we have here 45 degrees or pi over 4. And that's squared times d theta dt. D theta dt in radians per second is pi over 60. Okay. Next, evaluate cosine 45 degrees or cosine pi over 4. So cosine pi over 4 is square root of 2 over 2 squared times pi over 60. And then simplify, we have here 5 over 60. That's 1 over 12 times pi. So pi over 12. And then square root of 2 over 2 squared. That would be 2 over 4, right? So we now have pi over 12 times 1/2. Therefore, dx dt, or the speed of the rocket, is equal to pi over 6, and the unit is kilometers per second. Okay, we can convert this to kilometers per hour, and it's approximately 1884.96, say 1885 kilometers per hour. Okay.